right, so today I'm going to do a little mini lesson on acceleration. We're going to learn about what it is and how we find it. We're also going to review a little bit about speed and introduce velocity. And today we're really just learning it, and then tomorrow we'll put that into practice with what we're actually doing and you actually doing it on your own. All right, so just a quick review. I have three terms up here: speed, distance, and time. And just as a quick reminder, in order to find speed, speed is that relationship between the distance something travels divided by the time it took it to get there. I am going to introduce one new concept today, and that is velocity. Velocity is really similar to speed, which is why I didn't take a whole day to describe what velocity is. But velocity is equal to, let me get my right pen in here, speed, oh no, speed's supposed to be blue, speed plus whatever direction an object is going. So here you can see I have a full formula of velocity is equal to speed plus a direction. So an example of speed, just to write it out for you, would be 5 meters per second. An example of velocity would be 5 meters per second north. Or any other directional word you can give it: north, south, east, or west, left, right, up, down. It is some sort of speed going in some sort of a direction. All right, so let's talk about what our scientific definition of acceleration is. So, oh, that's such a thin little highlighter. Yeah. Acceleration is an increase in speed, so going faster, a decrease in speed, going slower, or some sort of change in direction. Now, before this point, we could have said that increasing speed, okay, cool, we're just dealing with speed. Decreasing speed, again, cool, just dealing with speed. But they went ahead and throw in this monkey wrench here that says direction or changing direction. That's an indicator that we actually are talking about this idea of velocity, or that change in velocity. Now, I'm saying change because we had the option to increase or decrease or change here some sort of velocity. So if I increase my speed going in the same direction, changing my velocity. If I go from 3 meters per second north to 5 meters per second north, that's a change in my velocity. If I go from 5 meters per second south to 2 meters per second south, that again is a change in my velocity. Or if I go 5 meters per second up to, now I'm going to turn right. One more time, change in my velocity. Now, we use the word acceleration outside of just science. When we talk about acceleration, increasing, we've talked about cars accelerate. Ooh, real bad handwriting today. We've also have a word for decreasing speed or decelerate. Now, I'm going to encourage us to not use that word and instead use this wonderful thought bubble down here. So when we talk about acceleration in science, we actually don't want to use the word deceleration, and we would prefer to use the word negative acceleration. The reason I'm having you do this, both technically get your point across, but when we're talking about negative acceleration, that is telling us right here, right from the get-go, that this negative is going to be by our number. So this is one way that I found to help you out understanding, like, oh, okay, negative acceleration means that I have to have a negative in front of whatever my acceleration is, which tells me right from the get-go that I am going slower than when I started. All right, so quick review before we get into our formula. we have acceleration really means some sort of change in our velocity. Okay, so we just talked through the idea that acceleration is the change in velocity. Now, technically, this means our final velocity, or where we end, also written as velocity with a little f next to it for final, minus our initial velocity, or where we started. So our initial velocity, where we started. And then we take that whole thing divided by time. Now, we use these little symbols up here at the top, VF and VI, so that we can keep track of where we start and where we finish. If we, for some reason, start at 5 meters per second, and then if we start at 5 meters per second, let me move this over so we have room to write. If I'm starting at 5 meters per second and I end at 2 meters per second, it's important to know which one is our initial and which is our final, because that'll actually give us very different answers. So if you just quick think about this, if we start with 5, technically that should be our second number. So we would do 2 minus 5, and that would give us -3, giving us a negative acceleration. But if we were to do this backwards or incorrectly, we might start with the 5 because it's bigger, and then subtract 2, giving us +3, which would actually tell us that we're increasing. So if we're thinking about this carefully, we want to make sure we know which ones are initial and which ones are final. That's the reason we use those little letters off to the side. All right, let me move it back. For our actual formula. So our official formula, acceleration, is equal to where we end, our velocity final, minus our initial velocity, or where we start, divided by time. And our label for this, because it is always important we include our labels, is going to be whatever let's say it's meters per second. We're going to work with meters per second squared. So when this is actually written out, meters per second squared. All right, let's go ahead and start with an example. One thing I want to point out to you, let me get my phone pointer out. Swoop. I have gone ahead and used all of these different colors to try and keep some sort of order as we're going through and learning these, so that you have an idea of how all of this fits together and we can keep some of our numbers the same. So, example. All right. So, Johnny wanted to practice his sprints to burn off some energy after having watched literally all of Netflix. He started at 0 meters per second going forward. All right, I'm going to stop right there. 0 meters per second. I know that that's a label for speed. However, I see that I also have a direction by it, going forward. So that's actually going to tell me that that's a velocity. That's the velocity I'm going to start with. And increased his speed, okay, again, I'm thinking it's speed, to 7 meters per second in a straight line. All right, I am still going in the same direction, so that's actually going to be my acceleration. And he did this in 12 seconds. So my time, 12 seconds. What is Johnny's acceleration? So I need to find acceleration in yellow. So I'm going to use my formula. Get this pen right. Acceleration is equal to velocity final minus velocity initial, so basically that change in velocity, divided by time. All right, so let's plug our numbers in and check it out. All right, so my final velocity, where I ended, increases speed to 7 meters per second. So I'm going to end with 7 meters per second. That's my velocity final, minus my velocity initial. I started at 0. Johnny started at 0. And then I'm going to take all of that divided by my time, which was 12 seconds. Okay, so when I go ahead and solve this, move my screen over a little bit, I subtract the top, and I have 7 meters per second divided by 12 seconds, and I am left with, let me make this into an equal sign, ha ha ha. I am left with 0.58 meters per second squared. So what this is basically telling me is that Johnny is increasing his speed to 0.58 meters every second. So every second he's adding 0.58 meters faster, 0.58 meters faster, 0.58 meters faster. So that is that increasing speed. This also, because it is a positive number, even though it's not a whole number, it's a positive number telling me that he is increasing in his speed or his velocity. So he's going faster. All right, let's try a second example. So Johnny, still Johnny, is driving down the road at 70 meters per second. So I am stopping here. I know that's going to be another velocity. Oh no, wrong button. Sorry, meant for the highlighter. 70 meters per second. When suddenly a deer jumps out in front of his car and he pushes on the brakes, slowing to 20 meters per second in a mere 25 seconds. Johnny doesn't swerve to avoid deer because that is dangerous. That is a little fun fact from Mrs. Beadle as you go to get your licenses in the upcoming 4 or 5 years. I know that it's less than that, but I'm hoping it's like 4 years. So what is his acceleration? So I already have a hunch here because he's pushing on his brakes, and I know how cars work, and I know you know how cars work, that my acceleration here is going to be negative. If he's going from a fast speed to a not so fast speed, I know that it is going to be a negative acceleration. So, checking back in with our formula, acceleration is equal to our final velocity, or VF, minus our initial velocity, where we start, divided by time. So let's plug in our numbers. I have final velocity ending at 20 meters per second. So 20 meters per second. And Johnny started at 70 meters per second. And that all happened in 25 seconds. So move our screen over a little bit so you have some space so you can see. 20 minus 70 gives me negative 50 meters per second over 25 seconds. Forgot my label here, my bad. Okay. And if I go ahead and solve this, Johnny has an acceleration of 50 divided by 25. Don't forget my negative. Negative 2 meters per second squared. So, as we predicted, our acceleration was negative because he is slowing down. So that means he is losing 2 meters per second every second that happens. This is not very slow. Johnny most likely just hit the deer because that is not very rapid negative acceleration. All right, that is it for our lesson on acceleration. Remembering that acceleration is that change in velocity, or velocity final minus velocity initial, divided by time, and then don't forget your label, meters per second squared. We'll actually go ahead and give this a try a little bit later, and let me know if you have any questions.